Hello everyone, today I'm going to talk about faster, cheaper, better, how the UK's Office for National Statistics is using data science and machine learning to strengthen our surveys. My name's Arthur Turrell, I'm the Acting Director of the Data Science Campus at the Office for National Statistics, and hopefully over the next 20 minutes I'm going to give you an idea of what could be done and what is being done by us at ONS to try and improve the insights and statistical analysis that we can do using survey data in concert with data science. And I do have to start with the usual disclaimer that these are my views and not those of the ONS or the UK government. Let's get started. So the first thing I want to say is a little bit about the Office for National Statistics. So it's the UK's largest independent producer of statistics for the UK. And the Data Science Campus is part of the Office for National Statistics in the UK. We're a centre of excellence in the public sector in data science. And our motto is data science for the public good. So we're always looking for ways to apply data science to produce better statistics, better analysis, and to basically improve the well-being of the citizens of the UK. Although actually some of our work is international too, and we're very happy to work with people. So that's the scene. Let me give you a little bit more information about ONS. It's a non-ministerial department, and we create many of the public-facing statistics that you might be familiar with if you're into macroeconomics, but also things like the COVID infection survey, statistics on baby names, and the census. So we really get involved in all kinds of things. We are non-ministerial, so we report to the UK Parliament too. Now, within ONS, I head up an area called the Data Science Campus. We've got about 90 people within ONS, mostly data scientists, and we're trying to bring this very new discipline to bear on the biggest problems the UK and other countries face. And as I said, our mission is data science for the public good. We love coding, we love machine learning, we love unstructured data, and we love innovation as well and trying to push the frontier. Okay, so that's the kind of context. Let me move on now to talk a little bit about some of the challenges with surveys. So surveys are brilliant, and they've done so much for statistics and so much for insight. And actually at ONS, we're setting up new surveys all the time in record speed. And we've had huge successes with them as well. For example, the COVID infection survey. And we run at the moment about 100 other surveys as well. But surveys have some challenges, and we need to augment them and provide alternatives if we're going to get the best and latest insights. So, some of the issues with surveys are that they can be expensive. Another one is that people may not always be truthful on them for reasons of just, not being able to remember exactly what they did when or how much they spent. And of course, there's a long running downward trend in response rates in surveys due to things like reduced contact rates. So there's a rise in single person households or reduced public willingness to participate as well. Some people may have security or confidentiality returns. Some people may be just suffering survey overload. And there's no silver bullet to solving declining survey response rates. But what we want to do is see how data science can help with all of these problems. So how can data science enhance the insights we get from survey data? The first way I want to tackle this question is think a little bit conceptually about what data science can offer. And I think there are lots of different ways to cut this, but I'm going to talk about a few of them right now. The first is that data science can offer better pipelines for incoming survey data. So pipelines here, what I mean by that is pipelines are the things that carry your data into the organization and through the building, if you like, even though that perhaps is happening on the cloud these days, and allow you to check and analyze it and basically work better with it. And I have a few examples of how data science can help with that. Now, the first and most obvious example are things like automation. Now, I don't suppose anyone will be surprised by this, but automation is easier than ever using modern programming languages and open source software. And scheduling bulk data transformations and checking and monitoring is easier than ever too. So there are now tools out there such as Airflow and Dagster, and I've put some examples of Dagster up there, and even GitHub Actions that can orchestrate complex data pipelines for you. And the idea here is very much to take the boring manual labor out of passing data around and processing it, and to do it at huge scales and in parallel. but at the same time to give operators all of the info they need on what's happening. And that stuff is a lot easier to do than it used to. As I said, there are a couple of tools that have been adopted by the big tech firms out there, things like Airflow and Dagster that you should check out, and Luigi as well. But also, it's because cloud computing is so much cheaper than it used to be, it's a lot easier to set up automation in the cloud too, and have some kind of event that sets off a workflow. And there's no reason for us not to use that and to automate the boring bits. And if we automate the boring bits, that gives our staff much more time to think about the interesting questions behind some of these things. Okay, so I'm going to move on now to the next thing that pipelines can do, which is, well, a question really, which is how often do pipelines fail when the real data arrive? You can do as much prep as you want, but what you often find is, great laid plans don't always survive contact with the enemy, so to speak. And you'll find that, great laid plans for data processing often don't survive contact with the data. So how can data science help with this? Well, the first thing is to test data pipelines for your survey data with some fake data. And there's amazing methods out there to generate lots and lots of realistic style fake data. So this is one tool. There are many other tools available called Mimesis, which, if you just grab some addresses and some locales, as in this example, you can generate lots and lots of fake addresses and locales specialized to the area that you live in. And there's an example on the right-hand side here of generating 1 million full names. And you can see that actually it's pretty fast at doing that as well. So fake data, you can push it through the pipelines and surface those issues earlier. Now, the other way that pipelines might be able to help, or fake data might be able to help, is going a step further and using something called synthetic data. Now, synthetic data is really interesting for statistical offices for all kinds of reasons. But here, what I'm thinking about is data you generate based on real data that has similar statistical properties to the real data and the same fields, but is otherwise fabricated. And it's fabricated with a certain tolerance of how easy it would be to unpick and go back to the real data. And the thing with synthetic data is it can help test data pipelines before the real data arrive and do it better than fake data because it's got the same structure, the same statistical properties to some degree. And I just want to do a bit of selling for some of the tools that we've been developing at ONS for this. So we've got a package called SynthGauge, which compares real data with synthetic data. And we've also got a tool out there for synthesizing a 1% teaching file of our census data called ReproSyn, which looks at a bunch of different ways of generating synthetic data to see how they do. So I really recommend you check out those tools. And yeah, synthetic data is an advanced form of fake data for testing pipelines. Okay, so the next thing I want to talk about is testing your code that does that data processing. So of course, everyone should be testing their code already. I hope you're doing that. If not, get on board because it's really a no-brainer, right? And I've lots of examples you could choose. On the left-hand side here, I've just got an example of running some very simple tests. And basically, if you throw in some data that doesn't comply with the tests that you've got there. In this case, it's, someone has put in an age that is less than 0, then it throws an error and you know that there's a problem in your code. And code testing has all kinds of benefits. It's very much borrowed from software engineering, adopted by data scientists. And we use it all the time in the data science campus, but it does several things. It checks the code does what you expect. It helps you find old bugs and even new bugs that break old functionality. So if new code is added and you check against the test suite, the existing test suite, then you might see that you've added something that breaks the old functionality. And it also encourages you to think really hard about the logic of your code as well. Now, as well as the traditional testing that's kind of set out on the left-hand side here, I want to talk about antagonistic code testing that goes a little bit further and actually tries to break your code, which is really interesting. An example of that is a package called Hypothesis, which really goes in and takes some regular code and does some data testing on it. So basically, it will, for all data, instead of specifying the exact data like an age that's -1, it will go in and create lots of data matching some specification, perform some operations on that according to your tests, and assert something about the result. And if it finds an example that fails, it will take that and simplify it until it can find the simplest version of that data that still breaks your test. So I think that's a really exciting development. Okay, so moving on. You can also test the data quality. So there are new tools around that test not the code, but actually what's in the data and have a look at it at great scales and with tools that are easy for lots of people to use because they go straight in and flag any issues. So I've chosen one such tool here. There are lots available called Great Expectations. And essentially how this kind of tool works is you set up a schema that says, well, I expect 90% of entries to be between these two values, and it will go in and it will check all of your data for that and create a report for you for when the data are failing those so-called expectations. So I think that's another one worth checking out too. Okay, I'm going to move on from data pipelines now and talk about how data science can offer complementary insights, can augment or perhaps even replace, in some cases, survey data. Now, I'm not going to labor this one because I'm sure you're all aware of the potential here. We've all been talking about it for a long time. And some cases are obvious, if there's very good administrative data on purchases through VAT or similar. But I do want to kind of, just remind you of the potential. So, there are two real types of complementary data around that you can think of. One is naturally occurring data generated in the course of economic activity that's not expressly collected for statistical purposes. And a couple of examples: payments data, mobile phone data. So on the left-hand side here, we have our international passenger survey compared to some mobile phone data that we used that recorded visitors to the UK. And you can see there's very, very good agreement there once we've rescaled things a bit. And then also administrative data as well, of course. So information created when people interact with public services, the schools, the health system, the benefits system, which are collated by government. And the classic example there is tax data. Now, there are some pros there, but obviously these things are not designed to answer exactly the questions we want. So there's some work in kind of doing data linkage, in converting the data to what we're really interested in. But I just mentioned that one. Okay, so next up, data science can also offer better processing of survey data as well. And what do I mean by that? So this isn't just about testing your existing processes. This is about improving those processes too. So a couple of examples here. So, powerful algorithms can do as well as human coders in classification. So, we can do better classification of the kind of entries we get. On surveys, sometimes there are free text fields, so they're a useful source of information, but historically difficult to process. And new methods in natural language processing can draw out common themes there. I can't talk about it yet, but there's some really exciting work on this coming out on some free text data on the Data Science Campus website in the next few weeks. So do keep an eye on our website and check that out, because it's a common problem that we've used natural language processing to help us with. Okay, so there I have given you an idea of some of the things that conceptually you can do, but let's move on now to talk about how we're already using data science to improve surveys. So this isn't conceptual, this is practical examples of things we've done. And I'm not talking about all of the examples that we have across the office here. I'm just talking about some of the ones that I and my colleagues in the Data Science Campus have been involved with. And I do want to stress that we're on the start of a journey here. We're making progress and it's really exciting. And I just want to give you a flavor of some of the concrete things that we've done. Okay, so and I'm going to draw them from those areas I mentioned, kind of pipelines, complementary insights, and also better processing as well. So pipelines, in preparation for the 2021 census, the ONS carried out a processing and outputs rehearsal to test those pipelines to convert raw census returns into published data sets. And key to this success of this work was having a synthetic data set that really had the same shape and fields as the new data that was going to be arriving. And actually, we were able to do that by re-engineering the 2011 census to the same format and test the pipelines. Now, why was this faster? We managed to reduce the time between the survey concluding and outputs being published. It was cheaper because the census is a huge operation. time saved is absolutely money saved. And it's better because it freed up time for quality analysis on the outputs rather than worrying about breakages in the pipeline because we tested it already. And you can see some of the early outputs from the 2021 census there, and check out our website for a lot more, including a kind of fun game. Okay, complementary insights. Got lots of examples from this around the office, just picking out two. So at the moment, we're using web scrape data to augment internal government surveys of local government in order to produce better estimates of local government expenditure. So that's currently collected by surveys of local authorities. By one government department sends out a form to local government. But what we're doing is we're augmenting this with data web scrape from local authority spending transparency data, because UK local authorities put some spending data up on their websites for transparency reasons. So it's faster because we get the information sooner, it's cheaper because it's low burden data collection, and it's better because we can get higher frequency, lower level geographies, and have fewer revisions in the data as well. Again, on complementary insights, we're using payments data to augment our understanding of the economy and the national accounts. So these are payments data from debit and credit cards. And, we've done a variety of things in this space. But one of the big benefits is having a more timely understanding of sudden shocks like extreme weather events, understanding how those relate to the bigger, more aggregate measures. It's cheaper because the card payment data is provided for free by these providers. We build up and work with them with good relationships. And it's better because we can improve some of our statistics. So for instance, we use these in trading goods at some point in the past. It's also better because we can measure consumption that's poorly captured in surveys, things like digital subscriptions, things that people don't always remember how much they've spent on, such as gambling. And then on better processing, we have developed a free text SOC coding tool. So SOC is do you know what? I've forgotten the acronym. Standard occupational classification. So, people write a free text and say what their job is, and we're able to convert that into a SOC code using an automatic coder. That's faster than humans. Human time is expensive, and it's better because humans can spend more time on getting tricky entries right. And we've looked at machine learning for doing this. We've looked at kind of static algorithms for doing that don't learn. And basically, we can do as well, if not better, than a human coder. And taking a human and putting them together with one of these algorithms produces better outcomes than either separately. So they're augmenting what's already there. We've got a paper out about this. There's also, you can find the code on GitHub as well. It's called Occupation Coder. So go check it out, download it, and play around with it. And I understand that there are people trying to use this in other countries as well. So hopefully you can adopt that for your local area and use it too. Okay, well, I just want to summarize now, and I know this has been a very short session, sorry, and I've gone through a lot of things. There are lots of ways data science can help surveys, and there are lots of things I haven't got time to talk about today. I'd really only scratched the surface today by talking about pipelines, complementary insights that could augment or replace survey data, and that's a huge field in itself, of course, and better processing. Hopefully, I've given you some flavor of how we can do things faster, better, and cheaper using data science today. And we're using all of these at ONS, and we'll continue to deploy them more whenever and wherever we can, because we believe that these can make getting statistical insights and analysis done faster, cheaper, and better. Okay, well, the only thing to finish is to say thank you very much for listening. I'm so sorry that I couldn't be there in person this time. I would have loved to have met you all. Please don't hesitate to reach out. I put some contact information on the first slide, so you can rewind and find that. But I'm Arthur Turrell from the Data Science Campus at the Office of National Statistics. Thanks for your attention.